Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 15th video in the Introductory Programming in Java full course and the 6th video of Lesson 3, Branching Structures in Java. In prior videos, we've looked at relational and logical operators, comparing strings, Boolean variables, checking ranges, if-else statements, and nested if statements. In this video, we're going to look at complements of Boolean expressions and assert statements. Let's get right into it. The complement, or opposite, of a logical expression is a different logical expression that always evaluates to true when the original expression evaluates to false, and always evaluates to false when the original expression evaluates to true. There can be no overlap, no cases for which both expressions evaluate to true or both expressions evaluate to false. If there's overlap, they're not complements. Let's start with a little quiz based on prior programs we've written in this lesson to get a sense of your intuition regarding complements, or opposites of expressions that evaluate to true or false. Ready to play? Here's your first question, worth 5 points. Remember this program called averageAltitude.java? We have an expression, altitude1 less than or equal to 0. The complement of this expression will always be true when altitude1 less than or equal to 0 is false, and will always be false when altitude1 less than or equal to 0 is true. Is it A, altitude1 less than 0, B, altitude1 greater than 0, C, altitude1 greater than or equal to 0, or D, altitude1 equal to 0? Remember, you can pause the video and think about it or try to work it out, so go ahead and do that if you want to. We're going to move right along to the answer. It's B, altitude1 greater than 0. The complement of less than or equal to is greater than. Moving along. For 5 points, do you remember this program, binarypuzzle.java? We have a Boolean expression, useranswer.equals binary string. Is the complement of that expression A, useranswer.not equals binary string, B, not useranswer.equals binary string, C, useranswer.equals ignore case binary string, or D, not useranswer.equals ignore case binary string? And the answer is B, not useranswer.equals binary string. There is no string method called not equals, and equals ignore case is not the opposite to or the same as equals. Moving on to moonweightcalculatorchoice.java for 5 points. We have the expression if choice equals 1. Is the complement of that expression A, choice equals 2, B, choice greater than 1, C, choice less than 1, or D, choice not equal to 1? Have you got it? The answer is D, choice not equal to 1. Even if the program asked the user to enter 1 or 2, it doesn't mean the user's going to enter 1 or 2. So the opposite of choice equal to 1 is choice equal to something else, or choice not equal to 1. Okay, moving on to double name that complement. It's going to get a little harder. In JShell in the last video, we wrote some range checks, and I actually told you which were opposites of the others. This is tricky. For 10 points, what is the complement of 400 less than or equal to CO2 reading and CO2 reading less than or equal to 800? Try looking at a number line to solve this one. Is it A, 400 greater than CO2 reading and CO2 reading greater than 800, B, CO2 reading greater than or equal to 400 and 800 greater than or equal to CO2 reading, C, 400 greater than CO2 reading or CO2 reading greater than 800, or D, 400 less than or equal to CO2 reading or CO2 reading less than or equal to 800? The answer is C. If you draw the two expressions on a number line, you'll see that they are exact opposites. A number will either make one expression true or it will make the other expression true. There are no numbers that will make both expressions true, but all numbers are covered by one or the other expression. How'd you do? Don't worry if you didn't get a perfect score. We're going to go over complements now, and then we'll talk about why they're important to know and how we can use them to error check our code with assert statements. Beginning with the relational operators, the trick is remembering that equality is always an option. So the complement of less than is greater than or equal to. It's natural to want to say greater than, but that's not the opposite of less than, because both expressions would be false for the number you're comparing against, since neither includes that number. You can also see this on a number line. Here I have x less than 0 and x greater than or equal to 0. One of them needs to include 0. All numbers have to be covered between the two expressions, with no numbers left out. So knowing that now, what do you suppose is the complement of greater than? If you said less than or equal to, you're correct. And then equal to and not equal to are the complementary operators. Now you can read this table in both directions, so the complement of less than or equal to is greater than, and the complement of greater than or equal to is less than. Now the logical operators are a little trickier, except for not. The complement of not is not having the not there. You can put not in front of an expression to complement it, since not gives you a logical opposite, but that's usually not a good idea. I'll talk about why in a moment, and when to use not. To complement and or, we use DeMorgan's theorem, which is to complement each expression on either side of the and or the or, and then change the and to an or, and the or to an and. It would be nice if and or were complements, but they're not. They're both true when the expressions on either side are true, and they're both false when the expressions on either side are false. So they're not opposites. But look at our ranges from the quiz. It's very easy to see DeMorgan's theorem when you're checking ranges on a number line. So look at 400 less than or equal to CO2 reading and CO2 reading less than or equal to 800, and you can see that the values 400 through 800 are handled by this range, or any values between 400 up to and including 800 will make this expression true. But any values not in that range will make this expression false. Now let's complement that. The complement of 400 less than or equal to CO2 reading is, remember the complement of less than or equal to, 400 greater than CO2 reading. And the complement of CO2 reading less than or equal to 800 is CO2 reading greater than 800. And then we switch the and for an or, and we get 400 greater than CO2 reading or CO2 reading greater than 800. And if we draw that on the number line, you can see that is true for the exact opposite set of values. You can also demonstrate to yourself that DeMorgan's theorem always works by writing up a truth table. Okay, now before we move on to the value of this, let me briefly explain why I wouldn't complement an expression with not. It is for readability primarily. Suppose instead of complementing the expressions on either side of the and in that last example, we wrote not 400 less than or equal to CO2 reading or not CO2 reading less than or equal to 800. Would you be confident you knew when that expression was going to be true and when it was going to be false? Compare that to 400 greater than CO2 reading or CO2 reading greater than 800. First, there's just less to read with the second expression. And second, it's hard to process a lot of negatives in natural language. If you put a not in front of a Boolean expression, you have to first figure out when it's true and then think about the opposite of that. Whereas with an expression without a not, you just have to think about when it's true. So I would recommend using not only in front of a Boolean variable. So for example, if not valid input. That reads more naturally. Okay, now why? Why do we need to know how to do this? It's so you can write correct code. Java and most other languages give us some shortcuts like the else statement. We can write if altitude greater than 0, do something else, and we've never logically expressed in the program when that else code is executing. It's executing when altitude is not greater than 0, but for what values of altitude do we get in that else expression? If you're the average person, you're going to say when altitude is less than 0 and forget about 0 altogether. But we know that it will execute when altitude is less than or equal to 0, because we know the complement of greater than is less than or equal to, not less than. So hopefully this knowledge helps us to always know what code will execute when the program is in a particular state. But to ensure that we have written our code correctly, we can combine assert statements with a thorough set of test cases. Let's look at moon weight calculator first. I've copied the program into a new program called moon weight assert, and I've changed the instructions to ask the user for a 1 if they want their weight calculated on the moon, and a 2 if they want their weight calculated on Mars. After the user has given their weight and chosen the moon or Mars, on line 38 there's an if statement. If choice equals 1, calculate the moon weight, and then else, calculate the Mars weight. Now a novice programmer might assume that if we're in the else, the user has chosen 2. Let's put an assert in there. inside the else, I'm going to write assert choice equals to semicolon. You can see that assert is a keyword. Now, what the assert does is error checking. It is going to throw an exception if the logical condition after the word assert is not true. That's all it does. It's there to crash your program if you make an assumption about the program state that's wrong. This is not a statement you would keep enabled in production code, but it is an important statement to help you when you're testing your program, because what it tells us is that the programmer has made an incorrect assumption, and therefore they do not understand all of the conditions under which some code is executing. That can lead to errors. If we believe that if we're in this else, the user has chosen 2, we are not considering that the user might have chosen another value. Now, by default, in Eclipse, asserts are not enabled. We need to manually turn them on. So go to the Run menu, Run Configurations, and then in the x equals arguments tab, under VM arguments, type -EA. That stands for Enable Assertions. Then you can click the Apply button and close. Now let's run the program. And I'll type 1 and then 100 for weight, and 2 and then 100 for weight. So far, so good. But now let me type 3 and then 100 for weight. And now notice I get an exception, an assertion error on line 42, where I have the assertion. So as a programmer, this should cause me to realize that I have asserted something about my code that is not correct. I have programmed with the assumption that the user will have chosen 2 if we're in this else, but it's possible for me to get into that else if the user hasn't chosen 2. And so I might want to fix my code, or I might want to clarify with the client what's supposed to happen if the user doesn't choose 1 or 2. Maybe we just never specified that. So what could we assert here in this else statement? What do we know without a doubt is true if we're here in the else? This is where complements are important. In an else, we know that the complement of the if condition is true. So what we can say with absolute certainty is that choice does not equal 1, because not equal to is the complementary operator to equal to. With that change, I can run the program and enter 3 and 100, and I don't get an exception because my assert is correct. 3 is not equal to 1. I do recommend putting asserts in your else statements and running with enable asserts turned on, because that will help you check your assumptions. It is very important that you know under exactly what conditions each line of code in your program is executing. I will talk more about testing and using assertions in another video, but here I wanted to show you the syntax, how to enable them, explain the purpose of assert statements, and give you the tools you need, complements, to write asserts in your else clauses. As usual, I have included an auto-graded exercise in the description of this video so you can practice choosing the correct complements for Boolean expressions. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.